Hello. Today I'd like to talk to you about Docker for pentesters. This isn't the first um, YouTube video, blog post, or whatever about Docker for pentesters. I've been using Docker for pentesting for about 2 years now, and I gave a presentation to my team back in 2018, and I've seen its use among pentesters growing. However, there's two things that I'm going to include today in this video that you don't normally see. In fact, I haven't seen in any other presentations about Docker for pentesters, and why I started using Docker in the first place, why I stopped using it after a while, and why I rediscovered it and why I started using it again recently. That's very unique to penetration testing, and we'll get to that last. But first, we need to talk about what is Docker, what is a container, and why it's useful. So basically, according to docker.com, it says a container is a standard unit of software. I think most people these days have heard of virtual machines. So if you look here at the graphic on the right, a virtual machine, let's say the infrastructure here is your hardware, it's your laptop or desktop, the hardware. And then you install something like VMware Workstation or VirtualBox, which is your hypervisor. And then you have the guest operating system running in each virtual machine with the apps in that running. As you can see here, this is a very thick approach. So when you look on the left under containerized applications, you have the hardware or infrastructure, the host operating system, you have the Docker runtime, and then each application or each container contains only the files and resources needed to run your application. You notice that there's no multiple guest operating systems here. Um, so there is one minor difference though between running Docker on various operating systems. When you run Docker on Linux, it basically runs it on what they call bare metal. If you run it on Windows or Mac OS, etc., then they're going to be running a very thin virtual machine and they won't be directly accessing the hardware. And I'm going to show you an example in a few minutes that shows why this is important. Now that we know what containers are, why would we want to use them as a pen tester? So my answer for that is have you ever heard of dependency hell, where you install an application and it installs dependencies or removes dependencies and basically jacks up other software applications? Now, there's things, for example, like Python. There's virtual environments that you can do, but what if it's not just a Python application? Um, and that's why I started to use Docker. So, like I said, I'm going to step through some basics about Docker, and then I'm going to get to, at the very end, I'm going to get to what I have not been hearing other people talk about when they talk about Docker for pen test and why it's important and what I think everybody is missing out on and where it really shines. So, I'm assuming at this point that you've already installed Docker. I'm not going to do how to install it. That's pretty easy to find if you go to docker.com. If you're on something like Kali Linux, and yes, by the way, I do install Docker on a Kali virtual machine, and I'll show you why in a few minutes. If you're on Linux, you can typically type in um, apt install docker.io to install it. Here, I've already got it installed on my Mac, so let's issue the Docker command. So there's different commands, and each one has different subcommands. One thing I want to point out, I don't know how many of you know anything about object-oriented programming, but there's kind of a parallel here between object-oriented programming and Docker images and Docker containers. So imagine that a Docker image is the same as a class in programming, and a container is like an instance of a class. Hopefully that makes sense and you know what object orientation is in programming. If not, I'll go a little bit further to show you. So Docker, oops, these are all the images I have. So let's look and see if we have any containers running. You can see I don't, with this docker-ps command, we don't currently have any containers running. Now, what I could do here is I could take any one of these repositories under the Docker images command, and I could run those multiple times. You could have multiple containers running at the same time. And so let's see. Oh, by the way, you might want to pause here real quick and go over to Docker Hub. If you don't already have an account, go to hub.docker.com, sign in, pause the video, and then resume once you've got an account set up, because this is going to become important in later steps. So let's see. I've already got Kali Linux installed here, but if there's any changes, it'll pull the latest. And this is what you do to install it: Docker pull and the container name. If you already have it installed, it'll pull any differences for the latest version. Now, if you come over here to Docker Hub, you can see that Kali Linux has the Kali rolling in here, and there's also Metasploit, the official Metasploit framework. One thing I notice is basically every week, anytime there's an update of the Metasploit framework, you can they basically update. You see here, it updated a day ago. So anytime the Metasploit dev team releases an update, they pretty much immediately release an update here on Docker Hub. So if you haven't already, let's install Kali Linux by running this command. Now, to actually run this image, run it as a container, we're going to run Docker run. And a couple things to keep in mind here is you normally would want to add in RM, and what that does is once you exit the container, it will basically remove the container. Otherwise, you could have containers using system resources in the background that never go away. And if you want to get an interactive terminal, you would issue the IT command, and then the name of your container. You can see it drops us into an interactive shell. So let's take a look at the root directory. Now, what if we want to share some files or directories on the host operating system? Let's rerun this and add in -v, which we're going to map a volume. And I want to map, first of all, let's take a look and see what's in the current directory. Okay, now that we've seen that, let's mount this directory as a volume. This is just simply a bash trick to mount the current working directory. And we're going to map that to / blah, whatevs, whatever, and then run it. Now let's look at the root drive. There we have our volume. So let's cat out the contents of that test.txt. And that's how we map a volume. You can also specify the, instead of the bash, exit out. You could have also used the actual path here. So before the colon is on your local system, after the colon is in the container. Now, what if we want to map ports? Let's just run this for a second. Oh, I don't have that installed. Anyway, what if we want to map a port between the host operating system and the container? We would add the -p option for port. And just like volumes, the host and the container comes last. So that's how you would map a port. So if this particular container wanted to, for example, open up a reverse shell or run a server that I wanted to be accessible on the host on my Mac, then I would add in this -P for ports option. Let's take a look at some of the aliases, by the way. These Docker run commands can get pretty long, so I typically use some aliases. Oops, be nice if I could spell. So here's some examples. I've got crapmac exec in here, the crapmac exec database, Covenant, which is a C2 framework, a Noom for Linux. I haven't been able to find a version that will run on Mac, so I run that in a container. And you can see since these are aliases, I can simply run, I can just enter the name of the alias. Oops, misspelled. Let's see some other ones I have in here. SMB map for scanning for file shares and mapping them as well. Let's see. Hydra, the password cracker. Well, not password cracker, it sprays passwords anyway. Couldn't get that to run on a Mac OS, so I set up this alias which basically runs this. If you remember, it's running it. It's going to remove it when it exits an interactive terminal. It's going to map the current directory, and I've got volumes mapped to some word lists. Now, some other great things about using Docker, in addition to being able to use the Docker pull command to pull down some pre-made containers, here in my GitHub repository, it's some of my Docker files. You can create your own, and I'm going to show you in the Docker file an example of the commands. So this is showing, this is going to use this base operating system. This is setting the working directory, and then run is going to run a command. Since this is using Alpine, it uses APK to install packages. It's going to set the shell. It's going to run another command. It's going to copy these certs into my working directory. It's going to expose these ports, another copy, running a command, and this is setting the entry point, which means that when it starts, unless I specify otherwise, when it starts this container, it's going to run this resource. And this is what's in the entry point. Now, Metasploit, although they already have a Docker container, something that's a little different here you'll be able to take a look at, and I have to give credit to somebody else for this, which I think yeah, right here. So if you pull that Metasploit container, you're not going to have database support. So Nima, I think, if I'm pronouncing the name correct, has this Medium article, and that's where I basically copied these steps from to give them credit. And this will basically create a bash function where if you type in msf-docker, it will also spin up your Postgres database. Because otherwise, if you just run docker pull and then docker run without going through these steps, you won't have database support. So that was very helpful. Thanks, Nima. And this also just showcases a few of the containers that I've created. You can think of these as sort of like recipes to build your containers. In fact, if you go over here on Docker Hub and click on any one of these, many times they have a link to their GitHub repository. Let's see if we can find one that does. See if this does. Because maybe you don't want to trust other people's code and you want to verify what's actually going into a Docker container that you'll be running on your internal network. You can see the source repository here. This way you can vet your tools and know that before you run something and say, for example, a client's environment or your work environment, you actually know what's going into this. So here you can check out their Docker file for Metasploit. And this shows you exactly what's in it. So if you wanted to, you could actually copy this GitHub repository, and from the same directory of this Docker file, you could run Docker build, and it would basically run all these commands, or you could just do Docker pull and pull it from Docker Hub. But I wanted to show that because you do have some insight and some control over what you're running. You don't have to just blindly install just yet another tool and not know what you're running in your client's environment. You can create your own so-called recipe. You can download it from Docker Hub. Now, let's take a look at a few more examples. Two of the things that I wanted to point out that I think is a little bit different that I don't think anybody else has been pointing out about Docker for pentesters. Let's switch over here to VMware. I already have Docker installed here. Okay. Oop. Sudo. Give it just a minute for this to download. I'm going to show you one of the differences between running Docker on a Linux operating system, even if it happens to be a virtual machine in this case, or running it on something like Windows or Mac OS. Now, I mentioned earlier that when you run Docker on Windows or Mac OS, that it runs the Docker runtime in basically a virtual machine. You're not getting access to bare metal. If you run it from Linux, you can actually use a couple of commands that will give it access to native devices and give it full access to the operating system. So you don't have to specify, for example, certain ports to open them. Here, it'd be easier just to show you instead of talking through it. So let's see, Docker run. First of all, now you see I have here on this virtual machine, I've attached a USB Wi-Fi adapter. Now on Windows or Linux, I'm sorry, Windows or Mac OS, you would not be able to see native hardware like this. So let's take a look at how running it on Linux differs. Forgot sudo. I think I'm getting these commands correctly. We're about to find out. Okay, so if config. Okay. I think it's in NetTools. Yeah, it's in NetTools. Okay, so you see we're actually in the container? I believe we are. Let's be sure. Yeah. So right now we're in the Kali virtual machine. Now we're in the container, and oh, that's right. I just exited out. So I got to run this command again. I forgot when I exited the container. Remember, I used the dash dash rm command, so that destroys the container. So I had to start over. That's a very important thing to point out is once you exit your container, all of your changes are gone. We'll talk about how to commit changes later. While that's running, well, okay, remember we're in the container. So see, we're seeing WLAN 0. That is a USB Wi-Fi adapter. Now let's look over here on Mac. Let's see. We already have a container. What I'm about to show you is although on running Docker on Linux allowed us to use the net equals host and privilege commands to actually attach to hardware as if it was native to the container. This is on my Mac. So now let's run this container. And let's use those same flags we used before. We can even run sudo, and I'll show you it doesn't make any difference. Okay, so let's see. Okay, you see all these other adapters? This is just in the bash shell on my Mac. See over here, even though I use the same flags, the privilege, the net equals host, when I started this container, it doesn't have access because, like I mentioned earlier, on Mac OS and Windows, it's actually running Docker in a virtual machine versus running it on Linux, which actually those commands will give you access to the actual hardware. Now that's the privilege flag. The net equals host will basically on this host since I started this using net equals host right here in Docker on Kali, if I run any applications that want to open a port, I don't have to stop, exit out, and rerun the Docker run command with that -p to map a port, because what will happen when you use the dash privilege and net equals host, it will give you access to the hardware, and if you run any servers that need to open any ports, it will automatically do that on the host. So it basically makes it run when you're running Docker on Linux, almost as if it was installed natively and not through a Docker container. Whereas on Windows and Mac, you're running it through a virtual machine and you cannot give it raw access to hardware or any raw ports like you can running on Linux. So that's why, or that's actually one of the reasons why, even in a Kali virtual machine, I will still install Docker, because it keeps my Kali virtual machine clean. It keeps all my dependencies for all my applications separate. And to simplify running things, like I showed you earlier, I'll just make a bash alias, so I don't have to remember the long, drawn-out command line flags to run particular containers, because some may have different requirements in the command line. So now, what if we wanted to easily create a container? So let's take a look real quick. What's something that we could install? Install Hydra. Now, normally, if I exited out of this container, it's going to, especially since I use the --rm option, it's going to wipe out any changes, and that base image will be left pristine, as if I hadn't typed any of these commands. It will not save any of my changes. So let's install this. Well, I guess I could have picked something that would install faster that's not almost 400 megabytes. Just bear with me for a moment till this finishes. So this is going to be easy mode for creating a new container. Is use your base operating system, whether it be Kali or whatever else, and leave it running. And let's do Docker PS. This is going to show you all running containers. Now copy and paste this container ID, and let's take a look at the Docker commit. So make sure this is finished. Okay, this is finished, and now we have Hydra installed. And if I exit out, it's going to wipe out all those changes, and it's going to be back to that stock image once the container is gone. So if we want to commit our changes, like I said, this is easy mode for creating a new container with only the tools that you want in it. We could use sudo docker commit, and let's see, options container repository tag. So at the very minimum, you're going to run in the command line that container ID of the running container you want to commit, and then we're going to call it Kali Hydra or something like that, and just hit enter, and it will save a new image with anything that you've installed in that Kali Docker container. So that's the easy way. The harder way of creating them frequently requires a lot of trial and error, but that's basically what I showed you here in my Docker files. That you basically would create a Docker file, which is essentially your recipe for building it. And once you copy, say for example, if you did git pull on this repository and you change directory to the same directory where this is at, then the way that you would build that Docker image would be Docker build. Let's see. Docker build. It's normally as simple as Docker build. Let's see. Trying to remember which one comes first. It's Docker build, the name of it, so name of your new image, and a period for the current working directory. And if there was a Docker file in this directory and you entered this command, it would basically build that Docker file and use that recipe, so to speak, to create a new Docker image. So let's say for a moment and that you've already created changes in your Docker container, and you have it all set up the way you want it, and you've already committed it, and you have a new Docker image. So this is one thing that I don't hear anybody else talking about and where this comes in handy in pen testing. Let's imagine for a moment that you're on a pen test, and in my case, a lot of my clients I work with work in the energy sector. For example, oil and gas and stuff like that, liquid natural gas, various companies, and they very frequently their networks will be segmented so that they don't have any internet access. They're incredibly locked down, and it's very frequently very hard and time consuming. If I wanted to do, say for example, an internal network pen test, it's not so easy to just say, okay, for my pen test, I want you to set up this virtual machine and open all these network ports. Very frequently, there's no option because it's not allowed to open up any network ports so that I can connect in from the outside and there to my Kali virtual machine or my testing platform, so to speak. And conversely, that means if I find myself in the middle of a pen test and I don't have a particular tool that I need, that virtual machine is probably not going to have internet access, so I can't install any additional tools. So imagine trying to install prerequisites for whatever application in Kali without internet access. Now, yes, there are ways to do that with, through Secure Shell, but what if your host can't connect out to the internet, period? And you've connected into this testing environment via a VPN connection or a VDI, and then secure shelled into that Kali virtual machine. How are you going to install additional tools? So this is someplace that Docker really shines. So let's imagine for a moment that you have this Docker container. We've installed our tools in it. Let's look at the export command and import. Sudo docker -h. See export and import. So you see it exports a container's file system as a tar archive. So even if your testing platform or your Kali virtual machine, whatever you're using, does not have internet access, so you can't just say, for example, use, if it's a Python application, pip install or apt install or whatever. What you can do is on a host that does have internet access, you can set up your container and then do Docker export and export this container's file system as a tar archive. And then on inside that client's network, where you don't have the internet access to install additional tools, you can run Docker import and import that tar archive, and boom, you have your application with all of your changes saved to it, imported from a file. So imagine if you're testing in an environment like this, you're either there in person or you have or you've connected to their environment from the internet over VPN or VDI or whatever. You simply would just have to import that tar archive into the environment through various means, and that solves your issue of installing new tools without having internet access on that system. So I hope you've enjoyed this presentation. To recap, basically, Docker containers are a way to containerize or contain applications so that you don't need a separate host operating system for as in a virtual machine. It basically runs, it's very lightweight. You only have the base operating system, and it's a way to keep all of your software prerequisites separate so it doesn't corrupt other applications and create dependency hell. We've also talked about how um, containers run in a lightweight virtual machine on Mac and Windows, but on Linux, I showed um, how Docker containers run natively, and therefore you can use the dash dash net equals host and privilege commands to connect directly to hardware, as well as open up ports natively. We've also talked about how to map volumes to the disk. And where that comes in handy is imagine that you're running a Metasploit in Docker. Now, Metasploit saves any files by default, and it saves settings as well, to your local user directory .msf4, I believe. So this is a way for your applications, if you run them using that -v option, amount of volume, locally you can create a .msf4 directory and map that into your Docker container so that it persists your changes. Even though the container is destroyed when you exit, it will still save its changes to that file. And in addition to mounting volumes, we talked about mounting ports and how that when running on Linux, you don't have to map individual ports if you use the net equals host and privilege commands. And so I had originally started using Docker because I wanted to be able to run Linux native tools that would not run on Mac or weren't ported yet to run on Mac. I wanted to be able to run those on my Mac without having to spin up a virtual machine for everything. So that's why I started running it. Then after a while, it kind of became cumbersome. But recently, while I was doing an internal network pen test for a client that I did not have the option to open any ports to the internet, so I could natively install tools in my Kali virtual machine, I found that containers running Docker was a way to, on another host, create or modify my container, use the Docker export command to export to a file, and then I was able to import that container tar file onto that system, and it had all my dependencies for the application to run, and without needing internet access to get it there. So I hope you found this informative. Please leave feedback if you have any questions, concerns, or if you'd like to point out anything I've missed. And thanks for your time. Thanks for watching.